Not too much to, someone's going, I'm not going to buy that, but enough that you're going to get some kind of little profit, right? But make sure it's not too low so you're not losing money when something happens, when there's an emergency. Cool? So there was someone behind the scenes coming up with these. They got this from looking at statistics, right? But they come up with that number. There was some math geek, right? They call them actuaries. It's like, put $350. All right, well, we're just going to compute the expected value. So what are we going to do? We're going to sum x times p of x. All right, well, let's multiply these. We'll put it here. Let's multiply these. We'll put it here. And then you and I will sum these two values. We'll add them together. Keep in mind, that's a negative, right? So this times this. I can do it on a big screen. 350 times 0.998937. I'm just doing it on a blank screen, right? All right. 350 times 0.998937. I get 349.62795. Hey, Autumn, I'm not going to round that until I'm done the final answer. Let me hit clear again. There we go. Everyone, I'm not going to round that number. I figure I'll add them together, then we can estimate, we can round the last number and get 2 decimal places or 3 decimal places. All right, what else do I have to multiply?
249,650 times 0.0.
Where's the negative button?
0.063.
Where's the negative?
I think it's like
Way at the bottom. I'm going to hit the negative. Negative 249,650 times 0.001, 063. All right, negative 265. 0.37795. And what am I going to do with these two?
add them.
This answer better be positive. Right? I hope so. So, all right, what's my last answer? Remember the answer button? What's my last answer? Plus that 349.62795. $84.25. That's the expected value. $84.25. There we go. $84.25. Hey, some of you might just do all this at once. When I did this on the screen, like, see how I did it? You might just go, hey, when I do this, I'll hit this off. I'm just going to do it all at once and just go, all right, here we go. What's 350 times 0.998937? And then, isn't plus and negative a subtraction sign? So I'll go minus 249,650 times 0.001063. I mean, so you can do it all at once. I actually like when you write it like this, actually on your tests, so I can see, oh, this, in case you make an error, I can go, that student knows what to do. They just made an error right here in the multiplication of this thing. They're all 1 decimal place or something like that. Cool. So great job with that. Hey, can we talk about this? Like, what does this really mean? Interpretation? Interpretation. I thought they're getting 350 from this guy, right? This is for Allstate. Allstate profited how much? About 84. We're saying they expect to. It's expected that they're going to get, on average, how much from each 18-year-old male who purchases a policy?
$84.25.
$84.25. I know. We're like, okay, what's that mean? I thought they're getting what? 350. So we got to imagine this. There's all these 18-year-old males right up here at the table. I got 350 from him. He's from Colorado. I got 350 from him. He's from Alaska. I got 350 from this. I'm the company. I work for Allstate. I collected 350 from this guy, 350 from this guy, 350 from. No one's dying, right? Okay. So my bank account here at Allstate, boy, is it increasing, right? I've got all this money in there. I'm going around. I'm collecting all this money. But then right here, this gentleman here, everyone, from Georgia, this 18-year-old male, was in a car accident, he passed away. Now he had a life insurance policy, so now I have to pay out what? I collected this from, but I have to pay out a gigantic amount to this person. So when you see what happened with that bank account, I collected all these 350s, then I gotta pay that out. So sometimes that happens, but on average, how much they gonna profit on average overall from each 18-year-old male? About 84 bucks. It's a nice small number. It's not too drastic that you're not scaring people away. Like, you know, there's competition out there. Like, I'm not gonna go with Allstate. I'm gonna go with this company, right? The same thing happens. I know we're doing life insurance. This is the same thing with like car insurance. So you can think of Geico. And Geico has a bunch of actuaries. The people who come up with these numbers are actuaries. So if you're into that, that's a cool field. If you major in mathematics, you can do mathematics, and there's actuarial science degrees. You can do a concentration in actuarial science. Take a bunch of exams, but it's really for math geeks. If you really like mathematics, you know, like doing spreadsheets and stuff like that. But it is a great career. So hey, any questions on this problem? Hey, cool. Before I leave this, the practice problems that I give you in the book, can we at least, we won't compute the answer, but can we set that up? Because the problem in your book, they didn't put it in a table. They put it in a word problem. So I want to make sure you and I can read a word problem and present the table, which is the probability distribution, the discrete probability distribution. Okay? Sound good? So this I mean, you could practice it. I know you're going to practice it for homework, but I didn't want you to go home and go, hey, it wasn't presented this way. It's in a word problem. So the problem, everyone, it's on page 332. And, whoops, it's number 27. It's another life insurance policy problem. Right? Put these out of here. But you and I will present this. Everyone, this is a life insurance policy for an 18-year-old female. And you and I will just set this up. Sound good? It's $250,000, by the way. Cool. All right, so it's a $250,000 life insurance policy. It's 1 year term. So these people, they got to pay it every year, right? 1 year. Maybe that value decreases when they get to age 25. True, just like car insurance. Or maybe it increases. All depends on the odds. A life insurance company sells a $250,000 one-year term life insurance policy to a 20-year-old female. Oh, so it's a 20-year-old female. Okay. So this is for a 20-year-old female. $200. All right. According to the National Vital Statistics Report, so these probabilities are not made up. They really got it from the National Vital Statistics Report. The probability that the female survives the year is 0.999544. All right, so I can put that as a probability, right? Mm-hmm. So you would set up your table. You're like, all right, 0.999544. All right, now what's this costing this 20-year-old female? They said $200. That's the cost of it. The policy for a 20-year-old female is $200. Where's the 200 go? Good job. So far, so good? Mm-hmm. So here's this word problem. Because a lot of these, we'll practice these textbook problems, or you might use the software like MyStatLab. They didn't give these two numbers. They didn't give them to us. So can we all compute these? Mm-hmm. First of all, this one, isn't it going to be negative? No. It's going to be very close to this. So I'm just going to I'll put a negative down, get it ready. Put my dollar sign, but maybe get a calculator if you can do this in your head. What's 250 grand? Just subtract 200 from it.
249.
Ooh. All right, 249, 800. Awesome, Autumn.
Is it always going to be negative?
Yep, always. Great question. And hey, I know all of this is life insurance. We could do auto insurance. Like, I don't know, you have to tell me the number, but you drive a car, so you probably has car insurance, you probably like a 6-month or annual policy, it's an amount, maybe around here, maybe a little bit more, but it's the same thing, you know, with the value of the car. So that's for the car, right? But something happens, the car's in an accident, they have to shell out a negative value, which means they're paying it out to you. Hey, here's your car, here's $10,000 for your next car, right? And then you're mad because you're like, man, my car's worth 17 grand, right? All right, now everyone, they didn't give me this number. How do I get it?
1 minus.
Yeah, try it on your screen, because sometimes when it goes in scientific notation, that's why I thought I'd go over here. I'll hit the lights. 1 minus 0.999544. I'm wondering if this goes in scientific notation, because it's going to be very small. It did. So I got to hit the lights. I want you to be able to see that. These are the numbers that are going to start coming up more often. 4.56 E negative 4. How can I write that as a decimal?
0 point,
Put a point,
then 4 zeros.
3 zeros, then a,
4.
and we can check this out when I put 3 zeros and a 4. 0.000456 is 4.56 E negative 4 because the decimal point was right here, and you notice it moved 1, 2, 3, 4 places. Cool. Let me hit the light so we can see that. So that's it. So hey, if it was E negative 5, wouldn't there be 4 zeros? Good. There you go. I know a lot of you like to write it that way. Cool. All right. Hey, you don't have to compute this now, but then compute the expected value of this. The question in the book, the way they wrote it, they said compute the expected value of this policy to the insurance company. So this is to the insurance company, meaning you're going to get the value that they get on average. And it should come out positive, right? If not, they're looking for trouble. Because you're talking, yeah, bankrupt. You're going to just, on average, you're going to be behind. There's no profit in there. There's no profit involved. Cool. Hey, great job. Let's do this again. Okay, we did our shooting baskets, life insurance policy. All right, let's have a little fun. Let's do this with the lottery. All right, so.
I got a one
The
question.
lottery. Oh, good, Art.
Listen, so if they have to say pay tax, do they pay tax on the $84 or like that is the profit?
That's a
right?
good question. That's a
Right.
really good question. You know, as part of that is some of that tax exempt. I imagine they pay it on both. That's a good question.
Because otherwise they can say that's a write-off or something.
Right. Exactly it. But I wonder then when you get that, do they pay the taxes on that 84?
Yeah.
All right. Now, when this is a lottery, these numbers I'm gonna provide for you, they're not made up. I'm taking it from a game called Keno. So I do wanna make, these are not phony numbers, I'm getting real lottery numbers. I didn't just wanna make them up off the top of my head. I don't know if anybody's ever played Keno. But here's a Keno card. You can play this game today. This game's played like every 5 minutes. You might have seen this before at like a local restaurant, and up there's a, you know, somewhere located in the restaurant, maybe the bar area, there's a TV set, there's a screen, and on that screen are just numbers popping up. And people up there, and they're taking a card, and they're filling out the numbers that they want with a little pencil, and they pay $1, and hopefully they'll win or not win. So we're gonna look at that, but they have different games. They have a 10-spot, 9-spot, 8-spot. We're gonna look at the 4-spot game. So this is the 4-spot Keno lottery. But you bet, it's a discrete probability distribution. And this is gonna be mine. All right.
How many times have you won?
This?
It seems you'd be good at that.
Yeah, this game, I will play.
Oh,
Do you wanna know why?
why?
Because I'm a math guy, right?
That's why.
And I know the odds, right, Liz? She knows, like, I don't play any lotteries. I'll play any, the only thing I'll play, Liz, is something that's free. If the game is free, I'm all game. I'll play. If it's free, I'm playing. Now, sometimes you get games like that, right? But Liz, that's a good question. Or hey, if someone gave me some game to play and my odds of winning were more than 50%, then I'll play. Then I'm playing. But if it's less than 50%, I'm playing because we talked about the law of large numbers. All right, so I'm going to put LL in. I might get lucky on what? Just one occasion, right? In a small sample size, I might get lucky that one time and win. And sometimes it's a social thing. You do it because you're with your friends. But let's say I did it every day. Well, the law of large numbers says that over the long run, the money I'm going to get is going to be very close to the probability of winning, right? It's going to tend to go towards that probability. So if my odds of winning are less than 50%, in the long run, I'm just going to lose what?
Money.
Money. It's like, no, I'm being honest, like, I'm just being stupid. That's why, you follow me? I'm just being, because law of large numbers means, hey, you're going to do this every day? Okay. Do it for 10 years, you're going to lose money. You're just wasting time. No, I won a couple weeks ago. Who cares? Law of large numbers. But hey, I'll play free games, everyone. And one time, like Redskins radio, you could register your name for a chance to be in one of those game things. I didn't even know what it was, but hey, all right, I registered my email address, my name. Well, I was watching a Redskin game. This is 2007, everyone, the fall. And I'm falling asleep in my rocker recliner at halftime, and I hear my name mentioned on the radio. It's a true story. I'm like, they just mentioned my name. They said I won a game. So I ran over to the computer and go, what did I register for? I'm quickly trying to find out what was called the drive, the Redskins drive of the game. And they said, now, after halftime, if the Redskins score a touchdown in the winning drive, I get free tickets to the next a game that year. I get to sit in the radio booth with the radio announcers. So I was all excited. If they hit a field goal, I get something very similar. All right? But if they don't get either of those in the first drive after halftime, I just get some lottery tickets. So when I'm pumped, and my adrenaline's going, because I'm like, is this a dream? Because I was when I was falling asleep on that rocker recliner. This is a true story. So the Redskins, the kickoff returner ran this ball back,